Hi guys, thank you for watching. This is Essence of Science, and today we're talking about the periodic table. I'm Amanda.
And I'm Dr. Abbasi for Essence. Now, 5 minutes ago, you told me nobody wanted to join our podcast in our team because it's so nerdy, right?
Yeah, it's a little bit nerdy. I mean, we do have a great team of highly intelligent people, but the topic's a little bit nerdy.
The
Although I
periodic
have to
table.
say, no, okay. It's a cool topic. The periodic table is, I mean, the basis of what we are, right? And like our existence,
Is
but it's,
everything we know, yeah.
yeah.
I called it actually periodic table a love story. Why do
Okay.
you think it is? There's a lot of love involved in the. See, you go to school, it's just a dry fact. They dump it on you, and people start hating, science and so on. Where it really shouldn't be. Science is exciting. Science is intriguing, and
Actually, yeah, and
lots of love involved in periodic table.
totally. And actually, now that you mention that, it reminds me of my teacher who I learned the periodic table from. And that's why I do like the periodic table because that teacher was just so crazy, so excited about everything. His name was Dale Swanson.
I want to say there is actual love involved in periodic table. I hope in the school there was no actual love involved.
No, he loved the periodic table.
No, I'm talking about woman and man love. That kind of love is
Okay.
in periodic table. And but I think it's all about how you present the science to people. And you're very right about that. That if you just throw the fact that people at in the school become dry, people just doze off and get bored and tune out. But if you bring the story, how things were discovered, it's a very, very different story. Like, I think we are all owing our understanding of periodic table to a very young, attractive woman, actually. Now, her name is barely anybody knows her, but we cannot talk about periodic table without talking about who put it together. Do you know who that was?
What is that?
It was Dmitry Mendeleev. He was a Russian scientist. By the way, he went to Heidelberg. He actually
He or
went.
she?
Dmitry Mendeleev is a man.
Okay.
He was born, I think, in 1830s or so. So, and then he was born in Siberia, where you just get depressed to hear the word Siberia because it is cold. It is like tundra and so on. It is far, far away from any kind of civilization and so on. And he was treated as well that way. He was the backwater kind of a boy that nobody took seriously. So he struggled his whole life. And the fact that he was smart certainly was good for him, but it was harder for him to move forward than anybody else, like somebody from France or Germany, or even somebody from major cities in Russia. But he did go to Heidelberg, the school that I went down. You probably don't know. The year I got into my med school in Heidelberg, we had this celebration, 800-year celebration of University of Heidelberg. So
Wow.
it's an old school. So by in 1850s or I think it was 1850s when he got there, or maybe later even, it was already the center of philosophy and science and so on and so forth. So he went there, he educated like many Russian at that time, and there's a background to that as well. The, even before that, there was one of the biggest player in Russian history, Catherine the Great. Very few people know, though, that Catherine the Great actually was German, and she really modernized Russia and created this, brought lots of people that could do the high profession and so on, smiths and iron work and so on, brought them from Germany to Russia. She truly single-handedly, a woman, modernized Russian empire, and it made it one of the biggest empire in the world. In that part of that was because she was Catherine the Great was from Germany, sent a lot of people from Russia to Germany for education. And so Dmitry Mendeleev ended up with a government-sponsored trip to Germany to learn chemistry, the newest, the hottest science. Like, at that time, still few people like Isaac Newton were thinking that you still can turn lead to gold, that all of a sudden they could produce things that for thousands of years we were depending on animal hoof to make glue. All of a sudden, you mix few things together and heat them up, and then you have this synthetic glue, endless. Now, you used to do like you used to go and poop on your field to fertilize it. All of a sudden, you could do things and so on with certain elements. You get things from the earth, mix it, and so on. Chemistry. The chemistry was the most hottest kind of things. That's how people became their own time millionaires or billionaires by our standard today. So he goes to Heidelberg, he learns everything. He have a very limited knowledge of things, how they are going. And then he returns back for a regular job. And he remembers that he was a Russian that played and from Siberia. He struggled. His whole life he struggled. His first marriage didn't really work out, and the second marriage as well, I guess Russian women are like Persian women, they are very strong-headed, wasn't going well. And I forgot how old he was, but I think he was in his 50s or even later. And he practically, just committed to this monotone and boring job at the university until he meets this very young, attractive Russian woman. And that actually gives him a lot of energy. After that, he writes in his diary that, he feels like a young man again. It gives him a boost of energy. And you'd be surprised how many of our most important scientists in the world went through the same process, like, Pavlov and lots of others like Heisenberg and so on. They their love life is what gave them energy to keep going. At that time, our understanding of the periodic table was our understanding of the elements was very, very limited. We knew few things. Now, like probably a dozen or 2 dozen of elements were discovered. Do you know by any chance what those elements were that they were discovered before periodic table?
No.
Yeah. Well, the electricity that was practically 100 years later after electricity was discovered and we could put it to good use. Okay. People still didn't have electricity at home, but in the universities and so on, we had electricity. We could people like, for example, did lots of different kind of tests. They put electricity in water, and they saw that you can actually have two different gas. One gas goes to the positive pole, the other gas goes to the negative pole. And they noticed that some brutal story comes out. They put a mouse under a dome. And the mouse, it took few hours or maybe half a day, but the mouse then died. And then they noticed if they put a mouse and a plant under the glass dome, the mouse doesn't die. So the plant must produce something that the mouse can need for breathing and so on. And then they put a candle and a mouse under a dome. And they notice when candle goes out, the mouse dies as well. Do you see how interesting that is? Beside the fact that you couldn't do that today, torture animal and so on. But they notice that there's something there in that air that all living thing needs, animals need, and plant produce. And actually, the name oxygen comes from that, oxygen. Okay,
Comes from what?
we're from oxidating, from thing that we burning. It's something that it needs for burning. Okay,
Okay.
so um, and they discovered little by little by eliminating other things that there is something in the air. As a matter of fact, they found out that about 19% or 20% of the what air is that thing that we need. The rest is something else. And they discovered when you put electricity on water, you have two parts. One is the same thing that if you feed it to that dome with the animal lives longer. Or if you feed a flame with it, the flame goes on indefinitely. And the other things that it's so these floaty things that it's just like is lighter than the usual air and so on. And they noted they come together in certain proportion. That's very important. I come back to that later. It is almost like not only a love story, but like as well a crime and detective story.
Yeah, I was thinking it's like a mystery story.
Yeah, it's like a mystery story. At that time, people already knew some acids and some basic solution like they had a good idea about like we used many of those materials for tanning of the skins of animals and so on, for bleaching and so on. So we had some ideas about lots of chemicals, but we didn't know how they work. And um, unfortunately, I cannot go millions and billions of years back, but I can go about 2,300 years back because just by power of thought, philosophers in Old Greek came up with the name atom. Do you know what's the meaning of word atom?
No.
No, have you heard the name anatomy or
Yeah.
tomography?
Yeah.
Uh, at, um, a or a at the beginning means not or uh, negate that, and Tom or Tommy means dividing, cutting, dividing, separating. So anatomy meaning up, dividing, and cutting. Or um, atom is the word for indivisible, something that you cannot cut into.
Yeah.
So about few 1,000 years ago, we already knew, like their idea was that you take a piece of gold, you cut it in half, there are still two pieces of gold, and you go on and on and on. And the idea was philosophically we achieved that thing that you must be at certain point that you cannot divide it anymore. Just by the nature of thinking about existence, we came up with that idea that at certain point you cannot divide it anymore. And that indivisible thing, we called it atom. So we knew atom exists, but nobody could visualize it. Nobody could really prove they exist and so on. As a matter of fact, do you know what year did we discover and by whom that the atom is really real, that really prove that the atom exists?
Was it
It's
Isaac
ridiculous.
Newton?
No,
I
Newton was in 1700 something.
then who?
In 1905, Albert Einstein proved that
Wow.
the atom really exists. I mean, until then, it was a theoretical thing. By the way, Albert Einstein actually had lots of mistresses as well. He was married to his cousin, and then he married to, I think, to another cousin, and then had lots of girlfriends and so on. He was a very interesting character as well. And in one of those, the sport, and one of his, exploration of his mind and so on, he came with the idea how to prove that the atom really exists. It's that's a different story. I can go on and on, but so at that point, when Mendeleev had this element, we knew these elements. We knew that this is gold. This is something pure. There's nothing else in it. Or this is lead. There's just this. There's nothing else in it. Now, wood, they would burn it and find out, oh, wood, if you burn it, you have water. You have another thing that comes from the mouth of people, carbon dioxide. And if you burn it in a certain way, you get certain other things, mostly, but then you get something that is like coal, like carbon, like something that, but then they start doing that. They start boiling, burning, putting electricity on things, and just taking everything from the nature and dividing, see what's made of. And then they end up with 3 dozen things that they couldn't divide anymore. They called them elements. Now, obviously, um, hydrogen was known. Hydrogen, I want to share my screen and show you the periodic table, because we cannot talk about periodic table not having it in front of us. Oh, the hydrogen we discovered very soon, and then was something that would burn wood, and then what we found out that when we burn the wood in a pot and make it ash, that whatever remains after burning wood, that pot ash is make the plant grow. That's why we called it potassium, potassium. Okay, and then we discovered like there's some metal that you can find like gold and so on and so forth. And then there's some, once we could really use the electricity, we start dividing things. Like we discovered oxygen, number 8, and so on. And then we discovered as well a few things that in nature are already there. So we practically ended up with 3 dozen of stuff, but we didn't know what they are. What we knew though, we knew that if they react together, they react together in certain proportion. Since hydrogen was the lightest thing we have discovered, give it number 1. That is the number you see, the atomic number you see on top left corner of the periodic table. And we discovered they come together in certain proportions. Like it always one part of hydrogen with one part gas-wise, one part of hydrogen with one part of chlorine, they combine together, or 2 parts of hydrogen with the 1 part of oxygen, the gases combined together, and so on. And then we as well found out that the proportion of their weight compared to hydrogen, that we noticed that certain the certain amount of weight of one correlate with a certain amount of something else. And that how we sort of start gaining knowledge about the elements. Are you falling asleep already?
No, I'm following along.
No. But at the end of the day, we didn't have really knowledge about how they are working until Mendeleev fell in love and had this boost of energy, and in a dream, actually. It's not said when he was dreaming if that hot Russian girl was with him or not. We don't know that, but it is well known that in a dream, all these elements, like soldiers, they went in lines. They stood in lines, and then he just woke up and ran to his lab. He took a piece of paper, and like his dream, he lined them up based on their properties and their weight. So actually, when he did that, he didn't do it, the way they are right now. Okay, he did it just the opposite. The column and lines they were reversed, and he lined them up based on the properties and how they behave. And he found out there are lots of empty spots. And just right there, like that, he said there are some elements that will go there. And then once he came out, actually people at first didn't accept it because again, he was who he was.
Well, and also not only that, but anytime something's new, it's not going to be accepted.
Yeah, yeah. Well, and then especially if that person is from Russia, because science would come from Germany and France and England, but Russia or Spain even, or that's not where the science comes from. Okay. So even then, if your name was Robert Smith, you would be more scientifically accepted than if your name was Dmitry Mendeleev or Ramon Cajal and so on. There's a different story about that. That's a different story. So humanity was this miserable all along, that we weight people based on their origin, even then. Either way, in his dreams, these elements like soldiers, they make lines and so on. He goes and organizes them. And then based on that, he can explain why, like until then, we just knew that one part of like two part of oxygen by volume combined with one part of oxygen and make water. But then when we measure that one part of hydrogen is like, or one part of oxygen weighs 16 times more than one part of hydrogen. We have no idea why it works. But if you now look at the periodic table, you see that even though the periodic atomic number of oxygen is 8, but it's 8 protons and another 8 neutrons, so it is 16. The atomic weight of it is 16. So once we organize them in that form, lots of natural behavior of elements could be explained. And then over the years, people found those empty spots that he predicted. And that gave him actually a lot of validity about that this is real. This really helps us to understand the nature. And then obviously, it went on, and we discovered more and more elements. Um, and then there were, by the time I was born, we had 104 elements in the periodic table. Do you know how many we have now?
Like, I don't know how many.
118. Just
And
in
so
my
and so that actually just confirms exactly what I always say, and you always deny that we don't know all of like there has to be more elements that we haven't discovered because that just shows you by the time you were born, from the time you were born until now, like 40 elements have been discovered.
that's 40. 104 to 118.
Okay,
14.
14 elements have been discovered in 55 years. So you're telling me that in 155 years, it's not possible we find one more?
I never said that we don't find more. Let me know. Some of those elements have existed only for a millisecond. So we found most of natural stuff up to atomic number like 90 something. We discovered many of this element, they come in variation, and some of those variation are not stable. Entire lead on the planet Earth is made out of uranium breaking into something else and lead. That's how lead exists on Earth. Or, not surprisingly, do you know what's the second element in the periodic table?
Well, I have it in front of me. Helium.
Okay, helium. Yeah, okay.
Yeah,
Helium,
but
why is it helium called helium?
I don't know, but I do know that we have like supposedly a shortage of helium.
That's a very good answer, but why do we call helium helium? What is perihelion? Have you heard of that? Or helium is the Greek name for sun.
Okay.
Okay, but sun has been called in Greek Helios for thousands of years. Why did we call helium after sun?
I don't know. I have no idea. Does it have to do with something with our solar, like,
It's a detective
I
thing.
don't know, just tell me.
Now, helium is so light, any natural helium goes to upper part of the atmosphere and get pulled away by the solar, solar storm and solar radiation away from there. So helium, we had no idea helium existed, but somebody smart, his name was Isaac Newton, discovered if you take a prism, put it in the sun, all of a sudden you have this what we call spectral line. You have first of all, you have the spectral colors, meaning you put the prism in front of the sunlight, all of a sudden it breaks into different kind of colors. And if you look carefully, there are some lines missing in that spectral color. And then they discovered that some of those lines, when you burn it like an element and turn the light of that element into a spectral line as well, like the prism, you can identify an element by heating it up, and by those missing lines, you can identify that that element exists in whatever it's getting burned. By the way, we still use that today to identify chemical material. So, yeah, it is actually, that science
It
is so
is.
exciting. So, they've discovered you put the sun's light in prism, you get all the line, all the colors, but then some lines are missing. And those lines that are missing, they discovered many of them correlate with the hydrogen. So sun must have a lots of hydrogen. But then they discovered there are some other lines that we don't know what they are. So the helium was discovered indirectly from sun. That's why they called it helium, because it exists in the helios in the sun.
Interesting. That's cute.
Yeah, that is cute. Until then, we had no idea. Nobody could find it until somebody went to these wells when they have oils and gas and so on, and noticed, wow, there's a small part on the when you have the natural gas and oil and so on from the earth. Part of that is actually this material, helium. Nobody knew what to do with it. Okay? Until we discovered it has properties that it's extremely important. It's an inert gas, that it cools in a very specific way. As a matter of fact, when you cool it, they couldn't do it then, but then they found out if you cool it down far enough, it behaves in crazy ways and so on. And it doesn't combine with anything. It's what we call a noble gas. That's why they call that helium and anything underneath noble gas. Okay. So, but that's how we discovered that. Now, guess how helium come in the Earth? Why can't we get helium from Earth? Same story. You remember I told you you get all the lead in Earth is made of uranium become lead. Uranium in a certain situation, certain kind of uranium, when it splits, one part becomes lead, the other part become helium. That's how we have helium there. So, but more or less, then people start discovering more and more of these elements, and then understanding how they behave, how they don't behave. Until I think 90 something, this most of these elements they come in variation, a stable variation, and then the one variation that behaves chemically like that, but for some reason it is not stable. Sometimes it was less heavy and sometimes it was more heavy. Now we understand the proton number of the proton make an element, but then depending on how many neutrons are in that atom, but then we have so-called isotopes. And some isotopes are unstable. Some isotopes are radioactive. Like everybody thinks uranium is radioactive. No, no, no. Only a certain kind of uranium is radioactive. But then we found out once we started splitting things that there are some elements that they're only unstable. There's no stable form of them. Like all the elements that are discovered since I was born, from 104 to 118, they are from literally linear accelerators.
So what you're saying is since you've been born, there's been no stable elements.
That is exactly what I'm saying. That all of them is the result of no. We had already when I was born, we had nuclear, reactors and so on. So we created lots of things and so on, and we found out that there is some radioactive stuff that they just fall into other things and so on. But then practically the same time I was born, they start having this linear accelerator. They take an atom like a proton. As a matter of fact, they take, helium or a proton or gold or something. They move it so fast that they reach a fraction of speed of light, and then they smash them together. By smashing them together, they found out there are some other elements that we had no idea, but based on what we once we examined them, we found out that they are elements with more than 104 protons. Almost all of them they live just like a fraction of a second. As a matter of fact, some of them are so rare, and what you have to do is so literally, so you have to spend so much money to produce them that a gram of some of them are like $100 billion.
Like which one?
I forgot which one it was, but let me go back and see that. Like some of them, like americium, they found actually they're radioactive, but they're so weak and so little. We found actual use for that. Like our entire the smoke alarm system is based on americium, is named after America. Okay,
No.
americium is after America. That we like in all or smoke detectors, there's a tiny amount of americium that if it's a smoke there, smoke acts like a literally resistant to get the radioactive material that comes from americium away, like alpha radiation, I believe. And then it blocks it. When it blocks, then the circuitry start saying smoke, smoke, smoke.
Okay.
Okay.
Mhm. Why in the 50s, like have you heard of the term depression glass?
No, what is that?
Depression glass is just glass that was made during the Great Depression that stores would give you for free.
Okay.
But why is something called uranium glass? Does it have uranium in it? I have some actually upstairs.
Actually, you can put uranium, lead, many, many different things in glass. Now, glass is not a univariably homogeneous thing.
But why did
Because
they put uranium in the glass? Was it to color it or what?
some of them are for color, some of them are for other properties like make it heat resistant. Some of them are to just make it give it special characteristic. Okay, so all those elements in the periodic table after in from 104 to 118, there's minimum amount of that produced in the linear accelerator. Now the beauty part of that is that until recently the scientists did not believe anything after 90 periodic table atomic number 90 can be really stable. But the quantum physics has predicted that they can be some stable higher number atomic numbers, but in nature they are so hard to produce that there is no natural thing of that, because you have, like, let's say I told you how from 104 to 118 how they are produced in linear accelerator. There are many of others that are produced in a nuclear reactor. When the universe started existing, there were only literally hydrogen and helium, and still 99.999% of the universe is still helium and oxygen. Okay, 3/4 hydrogen, 1/4 helium. Everything that we are so rare. So, but how comes we have other stuff on the periodic table? Without them, we wouldn't exist. If universe started with mostly hydrogen and helium. Now, the answer is the sun. In the core of the sun, hydrogen come together, become helium. Helium come together, become carbon. 2 carbon get smashed together, become 4. Carbon is 4, become oxygen. And anything between, depending on what hits what. It goes on and on until, and all of that, what happens is it requires more energy, more heat to bring heavier stuff, bring them together. But nature works in mysterious ways. When a star has used most of this hydrogen, then it produces less energy. Less energy in a star, gravity is pushing it in, energy and the nuclear reactor is pushing it out. So if it's less energy, it gets pushed together harder. Then all of a sudden helium get together, then carbon get together, then oxygen get together. It goes on and on until it produces iron. Iron is a bad thing for a star. When it starts producing iron, it actually doesn't produce any energy anymore, meaning that the gravity crashes everything together and the star explodes. And when the star explodes, in that ginormous energy that it produces, mostly through a process that called neutron capture, meaning that everything is so hot, so explode like a supernova. Have you heard the word supernova?
Yeah.
When a star explodes,
Yep.
in that place, if everything is so hot and there's so much neutrons, then this atom take a lot of neutron, and some of those neutrons turn into proton, and then we have everything else. And that is how we exist.
Beautiful.
Yeah, it's like a poetry.
It is
That's
like poetry. It's like an extreme cycle.
we are exploding stars.
We talked about that like a month ago, actually.
Yeah.
We did a podcast with stars.
What is a catastrophe for the star is produces almost most of the thing that makes life possible. Because anything that if you look at the periodic table, iron is 26. So from 26 to 104 or 90, where most of their life is based on, and we make no mistake, almost everything in the periodic table, vast majority of them, they have a place in life. Okay? So without exploding stars, there wouldn't be any life and no poetry, no love, no nothing. It requires a death of a star to produce what we are.
So true.
If that's not poetic and beautiful, I don't know what is.
It definitely is. Thank you guys for watching. This was Essence of Science, and today we talked about the periodic table. I'm Amanda Armagast.
Dr. Abbasi.